Hi. In this last lecture in this module, I'm going to talk about something known as the identification problem. And that is basically the question of how do you tell whether something occurred, whether people hanging out with each other look-alike happened because of sorting, because of shelling, or because of the standing ovation peer effect, right? Or to use the fancy academic terms, is this because of homophily, right? This idea that you want to, be with people who are like you, or is it because of peer effects? You want to you act like people who you hang around with. Well, in some cases, that's easy to figure out, right? So if you look at segregation patterns, right, by race, it's very clear that, this happens because of sorting, right? It's also true if you look at, this is a picture of a middle school. This is some data from James Moody. The yellow dots here are Caucasian students, and the green dots are African Americans. And what you see is you see these four clusters, right? Here's cluster 1, 2, 3, and 4. The pink dots are mixed race students, and what you see is that these kids have sort of sorted into groups based on race. Now you also notice, there's also this break this way, right? Because there's 4 groups. What's that? Well, this is middle school, so that's male-female, right? So basically you have white girls, white boys, black girls, black boys, creating 4 different social groups. And this, again, it's very clear, that's just sorting. Now there's other things that aren't sorting. So this is one of my favorite graphs. You can find this on the web. These are generic names for soft drinks. So if you go up here in the Northeast, right, or if you go out here in the West, people tend to say soda, right? If you live anywhere here in the great Midwest where I live, people will say pop. Like if I go to the restaurant, I'll say, oh, I'll have a pop. Give me a Coke, which if you go down into the South is what they call almost anything. So you can walk into a restaurant and say, I'll have a Coke, and they'll say, would you like a Dr. Pepper or an orange or a Coke? So Coke refers to any soft drink. So if you look around the United States, there's 2 soda regions, there's a pop region, and there's a Coke region. Now there's no way this is sorting. There's no way someone sort of grows up in the South, really wants to say pop, and so they move up here to the Midwest in order to live with the pop people. That's just not going to happen, right? So this is clearly a peer effect. Now there's 2 books that recently came out. One is called The Big Sort by Bill Bishop. The other is called Connected by Nick Christakis and James Fowler. And both of these books sort of make the case for one of these effects. So The Big Sort talks about sorting, obviously, and Connected talks about peer effects. And in those 2 books, you see pictures of things where they sort of argue that sorting is the cause and peer effects are the cause. Now, what's an example from The Big Sort? Well, here's political opinion. So what you see in 1976, each dark county is colored in where the Democrats won by more than 20%. And each gray county is one where the Republicans won by more than 20%. And white counties are counties where it was within 20%, so close counties. So this is what 1976 looked like. Here's 2004. Now, if you notice, the country's been filled in, and the places that aren't filled in are just a few states, like Minnesota, Michigan, Iowa, and Wisconsin. But other states are almost completely filled in. And the other thing is to recognize here that a lot of the very dark regions, which are majority Democratic, are cities. And so most voters live in non-competitive districts. Bishop argues that this happened because of sorting. The Democrats moved to be where Democrats are, and Republicans moved to where Republicans are. So people have sorted according to their political beliefs. Now you could also make an argument, though, that this happened because of peer effects. That people moved into Democratic districts, and there were more Democrats, so they just became Democrats. Well, here's some pictures from the book Connected, which argues for peer effects, and this has to do with happiness. Now, people who are blue here are unhappy, and people who are yellow are happy. So yellow is sort of sunny. If you notice, you see clusters of yellow people, and then you see clusters of blue people. So what you've got is unhappy people hang out together, and happy people hang out together. Now, what Christakis and Fowler argue is that this is because of peer effects. If you're unhappy but you start hanging out with happy people, then you become happy, right? But one can make the alternative argument that this is because of sorting. Now, if you look at smoking, you see a similar thing. Here's smoking in 2000. Now, the yellow dots are the people who smoke, and what you see here is they tend to be out near the fringe of the social network. And you see big clusters of people who don't smoke. So here there's a lot of, you can look at this and think, well, boy, this seems to be evidence of just this snapshot. You could convince yourself that this is evidence of peer effects in smoking. Here's one more, though, where it gets sort of problematic. This is the average number of hospice days that someone spends if they're chronically ill. Now, you'd think this should be pretty much the same across the country, yet you see huge differences, right? Like, if you look just in the state of Tennessee here, right? There's regions where it's, between 6 and 13 days, and then right adjacent to it, right there, it's above 23 days. And so what you see is you see these, like in here, up in Idaho, you also see huge disparities. Now what's going on here is where these lines are, when you see these sharp lines, those are probably different hospitals. So what that means is some hospitals are keeping chronic ill patients for a long time, and others aren't. So why is that? Well, that could be sorting. It could be doctors and nurses who'd like to keep people in hospitals for a long time move to one area. It could also be peer effects. It could be that people sort of do what the other doctors around them do. So when you get things like this, right, you see pictures like this, it's an open question. Which one is it? Right, here's one more. This is Medicare reimbursements per enrollee. So how much Medicare money do people get back? And if you look at this, like, I put this up because I'm from Michigan. Look at the state of Michigan. So you have some areas where they get a whole bunch back, in other areas where they get very little. And if you look in the state of California, you see massive disparities. Like these, you have regions where it's less than $7,000, right next to regions where it's more than $17,000. So there's massive variation in how much Medicare reimbursement you get per enrollee. And again, you could ask, is this because of sorting, the people who like to give a lot of government money move to one area? Or is it because of some sort of peer effect? People give more money because other people give more money. And these are puzzles. Well, let's see why we can't tell, why there's an identification problem if we just look at the pictures. So suppose we've got two types of people. We've got A's and we've got B's. All right? Now, let's look at sorting. So suppose we started out, we have two populations. One population has, 2 A's, 2 B's, and then 2 more A's. So there's 4 A's and 2 B's. And the other has 4 B's and 2 A's. If sorting went on, what would happen is these B's would feel unhappy and they would move down here, and these A's would feel unhappy and they'd move up there, right? And what we're going to get is all A's and all B's. Now let's think about what peer effects would look like. Peer effects, I've got 4 A's and 2 B's, and these B's would switch and become A's, and down here I've got 4 B's and 2 A's, and these A's would switch and they'd become B's. So what happens is in either case, I'm going to get one group of all A's and one group of all B's. And I can't tell. Did this happen because they sorted, or did this happen because there was peer effects? If I just have a snapshot, like if I just take out my little camera here, right, take a little picture, I can't tell. So how do we do it? How do we make sense of it? How can people like Fowler and Christakis argue that, no, this was really peer effects, and how can people like Bishop argue that this is sorting? Well, in some sense, we've already answered that. We've answered that because let's think about the process. With sorting, we start out like this, and we can actually see these people move. These B's move here, and these A's move here. So what Bishop does in his book is he gives evidence of people moving into districts where people are like them politically. So he literally finds evidence of Democrats moving into predominantly Democratic districts and Republicans moving towards Republican districts. That people choose their districts based on the political ideology of other people in their district. So when you look for a house, you don't just care about how many bedrooms and bathrooms it has, you care about whether your neighbors are Democrats or whether your neighbors are Republicans, right? What Fowler and Christakis try and do is they say, okay, to find evidence of peer effects, what we need to show is we need to show that these people, right, switched and became A's because most of their friends were A's. Now that can be difficult to do, right? In some cases it's easier to do in other cases. But to distinguish between sorting and peer effects, we have to have that sort of micro-level data, and it's going to be dynamic data, right? So Bishop is seeing people move, Fowler and Christakis is seeing people change their behavior. The point is, and this is why identification is so tricky, right, is if you just have the snapshot, you can't tell. You can't tell the difference. Now, let's go back to one of the big reasons why I think this course is important. That is to be a many model thinker, right? If you have lots of models at your disposal, multiple models at your disposal, you're just going to better understand the world. Well, we've learned 2 models that look at the same phenomena. That people, you go to some place and the people all seem to be, looking the same, acting the same, right? And they believe the same things. What we've learned in this module is that there's 2 possible causes for that. One cause could be that they've sorted into it. Another cause could be that there were peer effects. When I just see that phenomenon, I can't tell. There's an identification problem. So if I want to sort out, did this happen because of sorting, or did this happen because of peer effects, I need dynamic data. I need to sort of have more data over time. So that was another reason we have models, right? To help inform data collection. So if you want to answer this question, so suppose you're concerned about healthcare costs and you see this massive variation in reimbursement per enrollee, or you care about healthcare just in general and you see this massive variation in how much time people get in hospice and want to know what's best, well, You want to figure out, why is this happening? What's causing this variation? Is it peer effects or is it sorting? Well, how do you do that? How do you know? Well, you need better data. You need dynamic data to see, are people moving or are people changing? And then once you know what it is, you can start affecting policies, right, in order to get better outcomes. All right, thank you.